CS 3351 Digital Principles and Computer Organization. Topic is Binary Adder. Presented by Devi Visalakshi, Assistant Professor of CSE Department, Rohini College of Engineering and Technology. Binary Adder and Subtractor. Now we are going to see about binary addition circuits. Addition and subtraction are two basic arithmetic operations that must be performed by any digital computer. In both these operations can be properly implemented, then multiplication and division tasks become very easy. These are the four basic rules for the binary addition. That is 0 plus 0 equal to 0, 1 plus 0 equal to 1, 0 plus 1 is equal to 1, 1 plus 1 is equal to 1, 0. Here 1 will be the carry. So in the first three operations, each binary addition gives sum as one bit, either 0 or 1. But for the fourth addition operation, the result consists of two binary digits. Here, the lower significant bit is called as the sum bit, while the higher significant bit is called as the carry bit. Next, half adder, a logic circuit based on adding two 1-bit numbers or simply 2 bits is called as half adder circuit. The circuit has two inputs and two outputs. The input are the two 1-bit binary numbers and the outputs are sum and carry. This is the logic diagram as well as block diagram and truth table for half adder. In the above half adder circuit, inputs are labeled as A and B. The sum output is labeled as summation symbol and the carry output is labeled with C0. Full adder. A full adder is a combinational logic circuit which performs addition on the 3 bits and produces two outputs, a sum and carry. As we seen that the half adder cannot respond to 3 inputs and hence the full adder is used to 3 digits at a time. It consists of 3 inputs, of which 2 are input variables representing the 2 significant bits to be added, whereas the third input terminal is the carry from the previous addition. The two outputs are the sum and carry outputs. The following image shows the block diagram of full adder where the inputs are labeled as A, B and C in, while the outputs are labeled as summation and C out. So here this one is the block diagram of full adder as well as truth table of full adder. From the above truth table, we can obtain the Boolean expression for both sum and carry outputs. Using those expressions, we can build the logic circuits for full adder. But by simplifying the equations further, we can derive at a point that a full adder can be easily implemented using two half adders and an OR gate. Next, we are going to see about binary subtraction circuits. Another basic arithmetic operation to be performed by digital computer is the subtraction. The subtraction is a mathematical operation in which one integer number is deducted from another to obtain the equivalent quantity. The number from which other number is to be deducted is called minute and the number subtracted from the minute is called subtrahend. So here are the 4 basic rules for subtraction. 0 minus 0 is equal to 0, 0 minus 1 is equal to 1, so 1 should be the borrow, and 1 minus 0 equal to 1, 1 minus 1 is equal to 0. So in the above figure shows the 4 possible rules or elementary operations of binary subtractions. In all the operations, each subtrahend bit is deducted from the minute bit. But in the second rule, minute bit is smaller than the subtrahend bit. Hence, 1 is borrowed to be performed the subtraction. Next, half adder subtractors. As half subtractor is a multiple output combinational logic circuit that does the subtraction of two 1-bit binary numbers. It has two input and two outputs. The two inputs correspond to the two 1-bit binary numbers and the two outputs correspond to the difference bit and borrow bit. So this is the logic diagram for half subtractor, logic circuit for the half subtractor, block diagram for the half subtractor, as well as this one the truth table for half subtractor. Full subtractor. A full subtractor is a combinational logic circuit which performs a subtraction between the two 1-bit binary numbers, and it also considers the borrow of the previous bit, whether one has the borrowed by a previous minute bit. So a full subtractor has three inputs, in which two inputs corresponding to the two bits to be subtracted, and a borrow bit usually represented as B in corresponding to the borrow operation. That there are two outputs, one corresponds to the difference D output and the other output B0. This is a block diagram for full subtractor, and this is a truth table for full subtractor. By deriving the Boolean expression for the full subtractor from above truth table, we get an expression that tells that a full subtractor can be implemented with half subtractors with OR gate as shown in the figure. By comparing the adder and subtractor circuits and truth tables, we can observe that the output D is in the full subtractor is exactly same as the output S of the full adder, and the only difference is that output variable A is implemented in the full subtractor. Therefore, it is possible to convert the full adder circuit into full subtractor by complementing the implement A before it is applied to the gates to produce the final borrow bit output B0. Thank you.